Hello everyone. Today you are going to learn how to graph ellipse. Before to teach you how to graph ellipse, I want to give you what is the definitions of ellipse mathematically. In mathematics, an ellipse is a plane curve surrounding two focal points, such that for all points on the curve, the sum of the two distance to the focal point is constant. The distance from the point F to the point A, D1, and the distance from the point A to F1 is D2. Now, and the distance from the F2 to B is D3, and the distance from B to F1 is D4. The definition of the ellipse is the set of points that equidistant, the same distance from the focus F2 and F1. Then, the distance, when you add the distance 1 and distance 2, has to be equal to the sum of distance 3 and distance 4. All points that satisfy these conditions are points of the ellipse. When you're going to define the mathematical ellipse, we have two different equations, two different ways to represent mathematically the ellipses. In the left side, I have the one way to represent ellipses, and in the right hands, you have another way. What is the difference? Number one, in this case, it's very important that you recognize what is the value of the A and what is the value of B. Now, A, always A is the greatest value. A is the greatest value. When the value of the A is as the denominator of the expression that have the x, this graph is horizontal, like this, horizontal. That's the orientation horizontal. And when the a squared, is on the denominator, when you have the y variable, is the vertical, like this, vertical orientations. The centers is this point. I'm going to do this in example. I have these equations. A is greater than B. A squared is as the denominator of the expression with x variable. Now my ellipse is horizontal orientation, like this. Number one, the center of the ellipse. What is the elements of the ellipse? Element number one is the center. The center is h, is this value, and k. That's the center of the ellipse. H, k. And this is the point. This is the centers of the ellipses. Another elements of the ellipses is the vertices. The vertices, you say h is the value of the h, plus and minus a. Then you have a squared. To find a, you need to find the square root of this number. Now, the distance from this point to this point is one vertex is a. And the distance from this point to this point here is a2. Now, the distance from the center to the two vertices is a. That's the reason I add and subtract a's. Another, this is from this point, from this center, you add a, you have this element. You subtract a, and you have another vertex. Another element is the covertices. The covertices is when you, from this, the distance from here, from the center to this point, this distance is b. And the distance from this center to this another point is b2. Then this point and this point name co-vertices. the co-vertex is this, you subtract b, and then you add b, and you have the co-vertices of the ellipses. Now, the fuzzy is another two element. If this element is one fuzzy number one is this one, and this is another element here is fuzzy number two. Then, now, how to find this? The distance from this distance, let me change here the point. The distance from this point, this one, the distance from here to here is C, and the distance from the center to this another point here is C, and a C is the expression square root, you subtract a squared minus b squared. This is the elements, and now another two elements. The major axis is the distance from this vertex to the another vertex, and the distance is 2a. That's the measure of the major axis. And the minor axis is from this point to this point is 2b. This is all the elements when you have horizontal orientation. Now that's one examples. You see here 25 is greater, a squared is 25, it's a greater number, then square root 25 is 5, small number is b squared, and the square root of 4 is 2. H is 2, and k had to be negative 3, because to get here positive is because the value of the value of k here had to be negative. Now I have now a is 2 and k is negative 3. The center is 2, negative 3. When you plug in the center is 2, negative 3 is the center of the ellipse. Now, to find the vertex, you select the value of the h plus the values a, 2 plus a is 7, and you keep the y because in this case, the orientation is horizontal because the a square is in the denominator when you have the variable in the denominator when the expression of the value x. This is 25 is greater than 4. Now this is horizontal, and you subtract and you add the value of a to the value of the h plus a, h minus a, and you keep k constantly, and you have one vertex here and another vertex here. Now, another element is they are the co-vertices. You keep the h, you don't change the h, and you add b and subtract b, and you have another two elements. When you have these two elements, you can make a graph. Now, to find the fuzzy, you need to find the value of c is square root a squared minus b squared. It's 25 is the value. This 25 is the value of b, a minus b squared. This is 4, square root 21, 458. You add 458 and subtract 458 to the value of the h, with the fuzzy h plus and minus c. It's a one fuzzy, and this is another fuzzy. It's very simple. Next example. Now is when I have vertical orientation. In the vertical orientation, the big number on the denominator is in the denominator with the expression y. Now this is the vertical. And it's the same thing. Now the center is hk. Now because now it's a vertical, you add a and subtract a to the y value of the center. Now you add k and subtract k. Remember the distance from here to here is going to be a. The distance from this to this is going to be a. The distance from this to this is b, and the distance from this to this is b. When you have the center, you add b to the y, to the x value, to the h you add b, you subtract b, and you have the co-vertices, and with the vertices you add to the value of the k A and subtract A, and you have the vertex. The foci is similar, but now you don't add and subtract the value of the A. It's a K because it's vertical. And now the major X, always the big X's, is the major X, and the minor X is the small X's. Another example, now 81 is a denominator for the Y variable. This is A squared, this is B squared. A squared, B squared, H is 2, K is 3, and A2, A is 2, K is 3, you have the vertex. You add and subtract A to the value of K because it's vertical. Similar here, you add and subtract B to find the covertices because it's vertical, and this is the foci, and you make a graph. It's very simple. Now I want to do these two examples. Practice it. I'll give you now the time you can do this exercise. In this case, A is 49, B squared is 9, then horizontal orientation, because the big number here is behind the denominator, in the denominator with the X expression. In this case, the denominator here is greater than 16, is denominator of the Y. This is vertical, and this is horizontal. Now, I want to show you now how to do this one, but in this case is horizontal. I have our vertex in our problem. In our problems, the vertex is 5, 3. The vertex is 5, the H and K. Center is 5 and 3. Now, H is 5, K is 3. And now I'm going to make a graph. This is my vertex, H, K. Now, what is the value of A and B? The value of A is 7 because it's a square root of 49. 7, A is 7. The values B is a square root 9 is 3. 3. Then is 3. What is the vertices? The vertex is, because this is horizontal, I need to add A. When you add A, it's a one vertex. You need to add from this point 9. This is 1, 2, 3, 4, 5, 6, 7 to the right. Remember, the value of the A is 7 because it's the square root of 49. And if from this point you count 7 to the left, 1, 2, 3, 4, 5, 6, 7, another point had to be here. Now, when you plug in here, this is another point. I have my two vertices, vertex 1 and the vertex 2. Now, the covertices. The covertex is, you add B. How many B? B is 3. Now, from this point, you move 1, 2, 3. From this point, you move down 1, 2, 3, and we have another vertex like this. That's covertex 1, and this is covertex 2. What is the foci? You need to find A squared minus B squared is 6.32. And now, from this vertex, you subtract C, and you add C to the left and to the right, and you have another two foci. Okay? The minor X is this one, and the major X is this one. Finally, I can make a graph of the ellipses. Very, very simple. Now, I remember this, the focis, the label foci 1 and the label foci 2. Now, from the center, I move 7 units to the right, 7 units to the right because this is the value of the A, 3 units up, 3 units down because it's the value B. You find C. To find the foci, you need to calculate C like this, with this expression C. And now, because it's horizontal, you add from this point to the value of the K, to the value of the H, you add C for this foci, and you subtract C to this foci. and you have the graph of the ellipses. In another example, A is 121, A squared is 121, B squared is 16. Now it's a vertical orientation because the big denominator always is A squared. And the A squared is in the denominator of when the Y variable is present. Now in this case, the center is negative 5, 5. How to make a graph of this? Remember, this is the vertical ellipse. I have the center. In my center is this case, negative 5, 5. Now I write here negative 5, and I write here 5. And I'm going to make the point. That's the center. This is the center of my ellipses. The value of A and B, the value of the A is 11, is the square root of 121. This is 11 here. And the values B is 4 because this is square root 16. The values B is 4. Okay? Now I have now A and B. The vertices. How to find the vertices? Because it's vertical, I need to add H plus K. To find the vertices, this is my first vertex. You add the value of the A is 11. Now is the value of K. I have the center. K is 5 plus 11 is 16. I have 15 and 16. And you subtract now. You subtract now. I have now the distance from this, from the center to the vertex, had to be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 up and 11 down. And I had the vertices. To find the co-vertices, now you move 4 to the left and 4 to the right. And I have the co-vertices. And the foci, I need to find the square root. A squared minus B squared is 24. Now, I have the foci. From this, add this number. And finally, I have the equation of my ellipses. Okay? This is very simple. The step you need to do to graph the ellipses. This is one example. In this example, I give you these expressions. X minus 3 squared. The vertex is 3, negative 1. The value of the A is 4, because 16 is, and the value of the B is 3. Because 16 is behind the denominator with the variable Y, it's a vertical expression. Because it's a vertical, you add, you move from this point A unit up and A unit down, and you have the vertices. Now from this is 1, 2, 3, 4, because A is 4, A is 4. And from this one, down, 1, 2, 3, 4, because it's a vertical, and you have the co-vertices. To find the vertices, to find the co-vertices, you use B. From this point, 3 unit to the left and 3 unit to the right. 1, 2, 3, and a 1, 2, 3, and you make a graph. When you find the foci, is 2.6 from this point, 1, 2, 6, 0, 6, and from this 1, 1, from this one 1, 2, and 0.6, and you have the foci. And this way you can find, that's the step to make a graph of the ellipses. Thank you very much, and I hope that you have a beautiful day, you have a beautiful time. I see you in the next video. Thank you very much.